All right, again, no new lesson today. I only want to go over some of the homework from Friday. All right, and the ones I want to look at. Sorry, I'm going to pick the ones to go over today, since I wasn't here to pick the ones to go over on Friday. Although, I hope you watched the video. The handout that you got was from Mr. Conley, and we do it a little bit differently. So, some people said, well, I watched the notes and I watched the handout and try to make sense of them, and I get that they kind of go together, but they kind of don't. So, if the handout is bothering you, you can throw it away. It's fine. If you want it for more practice or more help, then there's nothing wrong on it, but it's not necessary. All right, the big deal from Friday is the definition of a derivative. So it's going to be like one line of notes, and then we'll do some example problems. Definition of a derivative. Got to know it, period. Like on the next test, we'll ask you, use the definition of a derivative to find the derivative of whatever. And if by the time we get to the test, there will be other methods for finding derivatives. Ethan, that's what you were asking about earlier. Like some of you know, there's some shortcuts that make life easy, and we will use those most of the time. But we're still going to test you on this, so you have to know this when we get there. And remember, derivative tells you the slope of the tangent line. F prime is the derivative, tells you the slope of the tangent line. The slope of that line at that point is the derivative. So if that point is 2, 7, and if the slope of that line is 1/2, then f prime at 2 is 1/2. The derivative of the graph at 2 is the slope of the tangent line at that graph. And then how we find that slope today and tomorrow, but not the day after that, is using this definition of a derivative. Again, shortcuts are coming. You know them because you're in either physics or you came from calculus BC. Like, you know good news is on the way, but for now, we've got to do it the long way. So number 17. F of x equals x squared plus x minus 3. And the directions say, find the derivative of the function by the limit process. Okay, it specifies because even though we haven't gotten there yet, the book author knows there's a shortcut coming. We don't want you to use the shortcut yet. We want you to use the limit process. So I need to find f of x plus h and plug it in and take the limit. So f of x plus h, wherever there's an x, we replace it with x plus h. The vast majority of mistakes on this section and the next section for that matter, and really for most of this course, are algebra mistakes rather than calculus mistakes. Some of y'all saw that on the test. Like calculus you set up right and then you messed up some algebra step somewhere. That's pretty common here. So my calculus is almost done. It's my algebra of squaring this. Hopefully you can square that without having to FOIL it all out. And the derivative is equal to the limit as h approaches 0. And now I've got to plug in all of that. For f of x plus h. Minus f of x squared plus x minus 3, all over h. So this is like a counting problem, keeping up with stuff problem. Like right? The algebra is not hard. The calculus really isn't hard. It's just be careful because there's a ton of terms there. Make sure you match up who goes with who. So x squared minus x squared will go away. X minus x will go away. Careful with the minus sign. I'm not going to take the time to rewrite this whole thing with the distributed minus sign. I'm just going to kind of keep up with it. Negative 3 plus 3 goes away. Here's where some people will start skipping steps. Everything that's left will divide by h, so some people will do that. I'm going to show the step. So I'm just going to rewrite without all the crossouts there. Just because it looks a little cleaner. But you could definitely skip that step and be okay as long as you're careful and neat. Speaking of steps you could skip. Some people have trouble dividing h into everything, so I'm going to factor out the h. And then it becomes, hopefully, really easy to see that you can cancel the h's. And now we'll try, I guess we were supposed to try substitution at the very beginning, but you would have gotten 0 over 0. Even right here, you would have had 0 over 0. Now that we've canceled the h, we definitely don't have 0 in the bottom. So let's try substitution again. 2x, because there's no place to substitute 0 in for h in that term, so that just stays 2x. That goes to 0. 2x plus 1. So the derivative of this function is 2x plus 1. But that's a lot of algebra to get there. Number 21. F of x equals 1 over x minus 1. Same instructions. Find the derivative using the limit process. So I first need to find f of x plus h. It's pretty easy for this one. Wherever there's an x, in goes x plus h. Definition of the derivative. Limit as h approaches 0 of, stick with the same color scheme here, 1 over x plus h plus 1. Leave some space, minus 1 over x minus 1 all over h. So that is going to be a major algebra headache. Do you remember how to add or subtract fractions? Just generally, not that one specifically, but how do you add and subtract fractions? What do you need? Common denominator. ugly, like, because both of those denominators are not pretty, so I need a common denominator.
Wait, why did I switch from -1 to +1?
Uh-oh, did I mess something up?
Like the blue.
Yep. Good catch. Looking for whiteout. Don't see any. Yep, that's supposed to be -1. I was so eager to get to the common denominator thing. Can I make a common denominator by just adding h top and bottom? Is that legal?
Yeah.
No. I mean, it would make the denominators match, but you can't add something top and bottom and end up with the same fraction. Right? If I have 2/3 and I think, whoa, I'll just add 1 to the top and bottom, and that'll.
That's 3/4.
That's yeah, and that's not the same as 2/3. So adding something top and bottom doesn't work. Multiplying is the only way to get there. So we're going to have to multiply the second one by x plus h minus 1, top and bottom. First one will multiply top and bottom by x minus 1. Again, the caution that this isn't so much a calculus problem as an algebra problem. Like, the calculus problem is getting it to where I can plug in 0 for h. That's the easy part. The algebra problem is adding crazy fractions. Alright, so the denominator is x plus h minus 1 times x minus 1. The numerator is x minus 1. And then this minus sign out front needs to go to everybody, or everybody in the numerator, minus x minus h plus 1. And then don't forget that's all over h. Algebra, 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 algebra. And limit as h approaches 0. If you get lazy and leave that off, that's okay, as long as you put it back at the end and don't forget about it. So frequently I leave it off. The trick with that is don't leave it off for good. Let's see. X's go away. 1's go away. Speaking of being lazy and leaving it off, that leaves negative h over x plus h minus 1, x minus 1, all over h. Getting there. I suppose I should still be checking 0, plugging it in, but I would get 0 over 0, so that's not going to work yet. How about canceling here? Is that okay?
I don't think so.
Or not sure?
You're the one with the college degree, so
So you'll trust me?
yeah.
I appreciate that. Well, let's see if we can figure it out without just play trust the teacher. Not that you shouldn't trust me. Let's keep it, change it, flip it. So keep the top, negative h, x plus h minus 1, x minus 1. Change it to multiplication. And then ran into a problem here with first period. How do I flip h?
1 over h.
Right, because that's h over 1 if you want it to be. So 1 over h. Let me ask again, can I cancel the h's?
Yes.
Yes. Now it becomes obvious that I can cancel the h's. But I'm kind of glad you were hesitant there, because fractions and fractions, people get messed up trying to cancel stuff when they shouldn't cancel stuff. So you're right to slow it down and see what's going on here. So negative 1. Now I'm remembering to put that limit back on, because otherwise I'd be left with an h in there. And the whole point was to substitute 0 in for h. So negative 1 over Well, that would go away, and I'd have two x minus 1s down there. So x minus 1 squared. Again, the first step of that was calculus, like that definition is calculus. This very last step, where we plug in 0 for h, that's calculus. But the rest of that was a big algebra mess. Two more. Oh, we're good on time. Number 23. It's rare that I'll work 3 different problems like from the same exact section of the homework, because the calculus in that section is always the same. The trouble is the algebra is so different from problem to problem that I don't mind taking the time to make sure we're okay here. So again, the calculus for all of these is the same. Limit as h approaches 0 of f of x plus h minus f of x all over h. Now, we had some limits like this before. I think there was one on the test even that was at least kind of like this. Sort of like that, yep. So on the test, how did you handle that? What did you multiply by? Yeah, the official term isn't the opposite, but I think I know what you mean. Change the middle sign. Anybody remember the official word for that? Conjugate. Don't need to know that word, but that's what it's called. You guys that need to take the missing page, this is on that page. So that's why we learned it, so that now that little algebra skill that was on that, now we're going to use that in finding a derivative. Tyler? Oh yeah. So that looks like a giant mess, but you remember when you multiply by the conjugate, good things happen. Square root times square root kind of cancels each other out. What about the O and the I FOIL? Cancel each other out. You can write it out if you want to, but that is a minus. The out one's a plus, so they cancel each other out. I'm not writing that out. The last, root x plus 4 times root x plus 4 is x plus 4. Careful with the minus sign though. Make sure it's going to get distributed to everybody. And the bottom we don't mess with because we hope that something cancels. And I got lazy again and left off the limit. That's okay. I'm still working through the algebra as long as I remember to stick it on at the end. Let's see. X is cancel. 4 is cancel. H's cancel. You kind of start to get the hang of these. Like the algebra looks awful to begin with, and as you start to simplify, it's like, oh, all this stuff starts going away. That's kind of nice. I better put my limit back on there before I forget. And I'm hopeful now Since I canceled the h's, that was the problem with 0 over 0. Hopefully that's gone now. So let's plug in 0 for h. That would be a safe stop, because the only thing left is algebra. A multiple choice test is going to go ahead and add those. So your safe stop versus your multiple choice answer. Again, hopefully it's never a big deal to see the difference between those two. But when you get to a spot where, you're like, wait a minute, what do I do there? I forgot that from algebra. Well, if you forgot it from algebra, we will assume you know it, which may or may not be a good assumption, but it's an assumption we'll make for you.
Can you not check with power rule now?
Yeah, you can. And so Ethan's question was, can we check with power rule? Well, you don't know the power rule, so I guess the answer is no. But when we get to the test, you will know the power rule, and you will be able to check all of these with the power rule. Some of them super quick with the power rule. So you'll still need to do this by showing the work, but yes, you'll know a shortcut that will verify your answer. In fact, what happens on the next test is people can get this answer using the power rule, and if they forget this, I have to really be careful, because if all I do is look at the answer, they're going to get it right because they use the wrong method, or they get this and then they try to backfill with a bunch of crud that may or may not be right because they're trying to show their work to get to what they know is the right answer. So, long answer to Ethan's question is yes, you can check using other rules that we will learn soon. All right, one more, and then we'll be done for today. Number 47. One like 47 is definitely on the test. Like, just straight up tell you now, 47 is on the test. Numbers change to protect the innocents, but it's the same type question. And I like 47. It's a very AP type of problem because there is almost no calculations in it. Like, you don't need a calculator. The algebra is super simple, but the concept is really tested well to see if you know what's going on. So y equals g of x. The tangent line to that goes through the point 4, 5. And the tangent line passes through another point 7, 0. And we want to find g of 4 and g prime of 4. People are going to be so frustrated when they miss this question on the test because there's no work to do. I mean, there's work to think about. There's not work to do.
Well, g of 4 is 5.
How did you know that g of 4 is 5?
Because it passes to the point of 4, 9.
Right. 4, 5 is on the graph because g of 4 is 5. I guess kind of thinking of it backwards. It might help to draw a sketch of this. It doesn't have to be perfect. So 4, 5 is on the graph, and it goes through the point, or the tangent line goes through the point 7, 0. So that means the graph looks something like that. I mean, who knows, but so that's g of x. There's my tangent line. So yeah, g of 4 is 5 because it goes through because the point 4, 5 is on the graph. There's nothing to do. G prime, what does this little symbol mean?
Derivative.
I'm going to show lots of steps here because this is what your brain should be doing. I'm going to write out what your brain is thinking. I don't expect you to write out everything. I don't want you to write out everything your brain is thinking, right? This means the derivative at x equals 4. But the derivative is the slope of the tangent line at x equals 4. So it asks for the derivative, But we know, and this is the key point. This kind of gets tested all year long. The derivative is the slope of a tangent line. The derivative is the slope at a point. So I don't know the formula. I don't know really what the graph looks like. I kind of just made this up to make it work. So I don't have a formula to find the derivative, but the derivative is the slope of a tangent line, and it told me some things about the tangent line. So how can I find the slope of that tangent line? Yeah, just algebra 1 stuff here. Slope formula. So let's see, that would be 0 minus 4 over 7 minus 5. Oh, and that would be a safe stop. And some of you did that on the test. Like there was a question that was something about slope or average rate of change or something, and you stopped there, and that's fine. A few of you kept going and messed it up. Speaking of messing it up, was this not... I'm doing something wrong?
-4 over 2.
I wrote the point down wrong. That's why. I knew that wasn't looking familiar. So 0 minus 5 over 7 minus 4.
-5 over 3.
It's -5 over 3. Yes, sir.
So what if you say that this is a safe stop, but it's not actually a safe stop?
So you will lose points because you haven't. If it's not a safe stop, that means there's calculus yet to go, and you will lose whatever calculus points are associated with the rest of the problem. So I mean, it's hard to answer specifically because maybe you've already done half of the calculus, or maybe even most of the calculus, but you left some calculus to go. Generally speaking, I try to take off 2 points for an algebra mistake and 3 points for a calculus mistake. Generally speaking. So you can avoid the algebra points if you can safe stop it somewhere. But you can't avoid the calculus points because you're taking calculus. That's why we're here. All right, so if you haven't done so already, today's assignment, it's not really today's assignment, Friday's assignment was page 103, 5 through 29 odd, and 47. And again, we did some of those. That's what we just did. So tomorrow we'll sandwich up a couple things, but it's 2 easy things, so that'll be okay. Plus we won't have to go over test or homework or anything. We'll just jump straight in.